All right, what's up, guys? In this video, I'm going to pick up some calculus here. We're going to do another integration practice video. So we're going to evaluate the integral from 1 to 5. We got x over the square root of 2x minus 1 dx. All right, so the first thing I would do for this integral is to just do a substitution. Now, the best selection for you here would probably be the square root of 2x minus 1, because letting u be everything under the square root isn't going to help us at all. So let's take the derivative. So when we take the derivative, we have to use the chain rule. That's going to be 1 over the square root of 2x minus 1 multiplied by dx. And solving for du, we'll get the square root of, or solving for dx, excuse me, we'll get the square root of 2x minus 1 du is equal to dx. But since u was the square root of 2x minus 1, we could actually write it as u du is equal to dx. Okay. All right, so now if you look at what we have x du. So we still have the original variable that we started with hanging around in there. Now, when this happens, there are two possible scenarios here. The first is that, and this is actually more common, you probably picked the wrong u, you made the wrong selection, and you need to go back and try to pick a different u, or in rare circumstances you picked the wrong technique. So maybe you're using a u substitution when you should have been using by parts, or maybe partial fractions, or whatever. So those are things that will come up. However, just because the original variable is hanging around in there after you've done the substitution doesn't necessarily mean you did anything wrong. Sometimes what you may need to do, which is what we need to do in this case, is we need to take our substitution, which was u is equal to the square root of 2x minus 1, and solve that substitution for x. That way we convert everything in terms of u. So just because after you do the substitution, you still have the previous variable in there hanging around, doesn't necessarily mean you did something wrong. Sometimes it just takes you to solve for that variable using the substitution, and that's what makes integration so complicated, because you really don't know what you're dealing with until you get the problem. So we're trying to solve this for x. So this just requires some basic algebra. So the first thing I'm going to do is square both sides, because I need to get rid of that square root. As squaring and taking the square root are inverses of each other, so we'll get u squared is equal to 2x minus 1. I'm actually going to turn this around and write it as 2x minus 1 is equal to u squared. That way when we solve for x, it'll be on the left hand side of the equal sign. Okay, so I'm just using some basic algebra here just to solve the equation for x. So let's add 1 to both sides. So if we add 1 to both sides, we'll end up with 2x is equal to u squared plus 1. And now divide both sides by 2. We'll get x is equal to u squared plus 1 all over 2. So what we did was we solved that substitution for x, and now we can convert everything in terms of u. Now what I'm going to do is I'm going to pull out a 1/2, because that's just a constant, and then I'll have the integral, and on the inside I can just write this as u squared plus 1 du. Okay. All right, let's change the limits. So we have to make sure we do that. So just go back to the substitution. So we get u is equal to the square root of 2x minus 1. Let's go ahead and change the limits. So that's going to be 2. I'll stick in a 1 minus 1. That's the square root of 1, which is 1. And then I'll have the square root of 2 times 5 minus 1. That's basically the square root of 9, which we know is 3. So the new limits are going to be from 1 to 3. Okay. All right, so hopefully you went me so far on that. So now all we have to do is evaluate the definite integral. So from 1 to 3, we'll end up having u cubed over 3. And I got my calculator here, by the way, just to make sure my calculations are correct. So what this is going to end up being is 27 over 3 minus, it's going to be 1/3, which is 26 over 3. This will be 26 over 3. When we evaluate from 1 to 3, u squared is what I'm saying. And then the antiderivative of 1 du is just going to be u, but it's going to be from 1 to 3. And that's just going to give us 2. So now we got 1/2 times 26 over 3 plus 2. Now, we need 26 over 3 plus 2, which gives me 32 over 3. So this is just going to end up being 1/2 times 32 over 3, which ends up giving me 32 over 6. But I know that can be reduced because I can divide the numerator and denominator by 2. And that gives me 16 over 3, which can't be reduced any further. And that's your answer. So your final answer for this definite integral is going to be 16 over 3. So let me write that down. So we're asked to integrate the integral from 1 to 5, and it was x over the square root of 2x minus 1 dx. The answer here is going to be 16 over 3. All right, that is your solution. So let me circle that for you. So let me know if you guys got any questions about how I got my answer. I'll be more than happy to talk about it further. All right, guys, I'll see y'all next time. Y'all take care.